Welcome to the second lecture on numerical methods and programming. Today we will cover pointers and arrays. Again, we will discuss how to use pointers and what is the special features, or what are the differences between pointers and arrays, and how do you use them interchangingly, etc. So before we do that, we will just go through what we discussed in the last class. That's we talked about how to create a program and the basic features of that, right? That is, what are the basic things which you have to do before we run a program. Let's first create a source code and then invoke a compiler to compile it, and then the compiler creates an object code, right? And this object code is then linked to the other objects codes or to a function library using a linker, right? So now this linking operation creates an executable, and that's what we would run on the computer. Okay. So this was one of the things which we discussed in the last class. So we also discussed what is the general features of a program is, right? So here is the general features of the program. Okay, so we have in the beginning of the program some header files. Okay, like here we have standard input-output header file and a math.h, okay, header file, and then you have variable declarations, right? And then you have constants or the assignment statements. Right? So there are two examples of here, constant statements or assignment statements. And I also said that we discussed in detail what kind of different kinds of variables are. And we also said that when we invoke a compiler, okay, it's done in 4 stages. That is, first there is a pre-compiler which looks at all the include files, right? And then the second stage, it looks at all variable declarations, all variables are declared, etc. And in the third stage, it creates the code understandable to the machine. And in the fourth stage, which if invoked, okay, actually rewrites the code to improve the performance. Okay, that's the optimization. Okay, that's the 4 stages of the code is. Okay, so that's what that's the second aspect which we discussed in the last class. And then we also discussed various data types, that's the variable declarations which we make. What are the various data types? Okay, so we said we have integer type, and we have floating points, and we have characters. Okay, so these are the 3 different data types which we discussed. Okay, so inside integer we have short integers and long integers, okay, and we have unsigned integers. So the biggest integer which you can get is the unsigned one, because it even uses that bit which is reserved for the sign. I also said that normally all compilers, when you say integer, it takes it as a long integer these days. And a floating point also, you could have short or a single precision or double precision. Okay, so that's 2 different types of floating points. So that's a different data types which we have. Okay, so that's a summary of the last class. So today we'll be discussing pointers and arrays. Yeah. So what are pointers? So pointers are variables which point to memory locations. Okay, so it's something which points to a memory location on the. We'll see that how this is actually done in a little while. Okay. So like the variable, every pointer also has a data type associated with it. Okay, this is very important. Every pointer has to be associated with the data type. Okay, you cannot change the data type of the pointer within a program. Okay. So how do we declare? So now, we saw how to declare variables, right? So similarly, how do you declare a pointer? Very similar as that of the variables. Okay, the pointer is declared with a asterisk in front of the variable name. So if you have an asterisk in front of the variable name, then that's a pointer. Okay, for example, So here is one of such declaration. Okay, it says integer and a star, an asterisk, and number. Okay, this creates a pointer called number. Okay, so if you don't have this, then we know that it's our variable declaration for number, right? Integer number. Okay, now we have an asterisk here, and then that's a pointer. It's clear? And so then one important thing which you should remember, that you cannot create a pointer. That's, I'm repeating this. That's you cannot create a pointer without identifying the data type. Okay, so that's very, very important. Okay, first you have to identify the data type, and then you create the pointer. Okay, so we will see some examples of this here. Okay, so here is so here is an example of the use of pointer. Okay, actually there are two types of pointer. Here there is a file pointer and there is a floating point here. Okay, so Z here is a floating point which is a pointer. Okay, so it's, so if I said float Z, it would have been a variable Z, but I have a floating point pointer here. Okay, so this variable Z. Okay, so star Z. So now I've shown you how to use that. Okay, so here if you'll go to the what actually happens in this code in a little while. Okay, so here I'm using it. So I'm saying that so for example, the normal floating point is have x and y are normal floating point variables. So I could just assign a constant saying y equal to 10. Okay, so that's a floating point and assigning a variable a value to that y. Okay, but Z is a pointer. Okay, so I cannot assign a value like that. Okay, so how do we do this? Okay, that's what I wanted to show you here. Okay, so for every variable when you declare, okay, so there is a name which we gave it to it, right? And then there is an address, right? Okay, and there is some content in that address which we put in. Okay, that's what we do. Okay, so when we say integer n, for example, okay, so there is a name n which is given to it, right? And there is some address. Okay, there is some address to the memory location, correct? And then there is a content. Okay, the content is here 0. Okay, we are not putting anything, so it's a content 0, null. Okay. And then I said integer m, so again it creates a name and an address, right, and a content. Okay. So similarly, if I had said here floating point x and floating point y, okay, so it would have a name and it has an address, right, and some content in that address, okay, which whatever we put in. Okay. And then now let's say I declare a pointer, okay, integer star num. Okay, as num is a pointer. Okay. So then what happens? So again the name is now the variable name is star num. Okay, that's a variable name. Okay, it has an address and the content is 0. Okay. So now so now this is our initial thing. Okay, so now let's say I do something like this. Here I have said y is equal to 10. Right. So similarly, in this example here, I use as integer. Here I'm using a floating point, and here I'm using an integer. Okay. So when I say n equal to 6, okay. So what happens? The content of that variable n changes to 6. Right. Okay. So now, so that's what we did. We changed n equal to 6, and then now we are going to use we are going to point the pointer to a location. Okay. So we have this pointer num. We want to now point that to an address, okay, of the variable n. Okay. So we are going to point num, the pointer num, to the variable n. Okay. So this ampersand sign. Okay, this is one of the operators associated with the pointer. Okay, there are two operators. One is the asterisk sign which we saw, and another is an ampersand sign. Okay, so now this ampersand sign will actually return the address of the variable. Okay, so that's what this ampersand sign do. Okay, so if you have ampersand of any variable, it will return the address of that variable, and that address is now associated to this pointer. So then what we see is that this pointer num. Okay, now we have notice the difference here. It is just num, not star num. Okay, the num is now as a content, which is basically the address of n. Yeah. So that's what we're doing. So here, for example, I said y equal to 10, okay, and I said z is equal to ampersand y. Okay, so now this z is now pointing to the value, pointing to the address y. Okay. So now when I say x is equal to star the asterisk sign z, okay, now it returns the value to which the pointer z is pointing. Okay, right. So where is z pointing? Z is pointing to y, right? Okay, so asterisk z, star z will return the value of y. Okay, so that's what we would see here again. So let's look at that. What actually happens? The ampersand operator returns the address of its argument. Okay, remember that. That's one argument which we use. Okay, one operator which we use is the ampersand operator. Now, so I'm just summarizing this again. So you say num is equal to ampersand n, means it sets the pointer num to the address of the variable n. Okay, so that's one of the basic usage of that. Okay, now let's see. We go ahead and see what happens if you assign something like x is equal to star z, which I said there. Okay, so here I say m equal to star num. Okay, remember num is pointing to variable n. So what should happen to m? So m should get the value which is of that of n, right? Because this star num will return the value of the variable to which num was pointing to, right? So we would make the m to go to 6, right? Okay, so that's so otherwise the star num had the value of n. Okay, that's what this is. Okay, so that's what we said that. So we saw another operator that's called the indirection operator, right? So that's what we use this. One we saw is the ampersand operator, which actually points to a particular address. Okay, and then we have this indirection operator, okay, which is the asterisk sign, which sets the value of m to that pointed by num. Okay, right. So here it sets the value of x to that pointed by z. Okay, so if you want to print out the value to which z is pointing, then you would again use here, for example, you can use star z instead of x. Okay, so we'll see how this works. We'll just execute this program and we'll see what we get. Okay, so it's printing out two numbers 10. So let's see what we did. Y equal to 10 I assigned, and I put z equal to z. I pointed z to the ampersand y, right? So I pointed z to y, right? And then I assigned to x the value to which z is pointing. Okay, so that's 10. So both of them will get z. Okay, so I could also do this. I could just also we'll try this, and so it prints the same thing. Okay, so it basically returns that value to which it's pointing to. Okay, okay. So now, for example, let's make this statement n equal to 6, and we say num equal to ampersand n, and then m equal to star num. Right. So that's the same as, right. It has the same effect as the statement n equal to 6 and m equal to n. Okay. So why do you want to use this? Why do you want to use this ampersand sign and the pointers? We'll see that in a little while. Okay. So that's what the summary of this part is that we had the ampersand sign to return the address, and we had the asterisk sign to returns the data to which it is pointing to. Okay, so that's two basic operators associated with pointers. Okay. Okay, so now we saw now how to use pointer on one side. Okay, right. So we, for example, in this program, we use pointers. Okay, so on pointer on this side using an asterisk sign, and pointer on this side where we had used the ampersand sign. Okay, so this is not necessary. It's not the only way to do it. We can use pointers on either side. Okay, so that's what we would like to see. Okay, so let's again look at that. So we had n equal to 6, and then n pointed to that, right? And then we said z equal to ampersand n, and then z actually pointed to that address, right? Okay. And now we say m equal to star z, so then m would take the value of n. Okay. So now what we can do is, now I can say this asterisk z is equal to 9. Okay. So that's using the pointer on the other side, right? So see here I had used the star z on the right hand side of this equation. We can also use it on the left hand side of the equation. Okay, so that's what this is. So here that's what we are doing. We are using the other side. Okay, so now what would happen is that, see, my pointer z is pointing to n, to address n, right? And I'm changing when I say asterisk z, which basically is returning the content of the variable to which z is pointing, which is n, right? Okay. So now if I do that, okay, so then I will actually set the asterisk z to 9, and then that would change the value of n to 9. Okay. But the value of m will not change. Okay. So that's a difference here. Okay. So I can, if I change this, because I set z to point to the address of the variable n, right? If I change asterisk z, the value of that, that is the value to which z is pointing to, that will change the value of n. Okay. But m is given a constant assignment there, that doesn't change. Okay. So that's the difference between assigning a constant and pointing to and using a pointer. Okay. So that gives you one of the differences. So this screen basically is supposed to illustrate two things. That is, one, that I can use this on the left hand side, not necessarily only on the right hand side, and that if I point a variable, if I point a pointer to a variable, and if I change the value of the pointer, that is the data to which it is pointing to, then that variable also automatically take that value. Okay, that's what it is assigned. Okay, we can look at this using an example again. So here I'm trying to show exactly the same. So with the example, I am trying to demonstrate what is listed here. Okay, so here I have a program in which I have declared a pointer z, again a floating point pointer, and I have two floating points x and y. So now what do? I have given a constant assignment here, y equal to 10, and I just going to point my pointer to that variable y, right? Okay, and then I am going to assign that data to which the pointer z is pointing to a variable x, right? Okay, and then I will print out that here. Okay, so I will print out both y, which will be 10 here, and x, which should be 10, because x is given a value to which z is pointing to, which is 10. Right? And then I said change star z to 9. Okay, and then I want to print out y and x again. Okay, that's what we're going to do. Okay, so we have the first printout, that is when we printed here, okay, I got y as 10 and x as 10, okay, and then I changed the data to which z is pointing to, okay. So that's basically the value of y, okay. I changed it to 9, okay, but what x doesn't get changed by that, okay. So when I changed this one, okay, it doesn't change the x, it changes the y, okay. That's what we see here, okay. So it changes the y to 9, but x remains 10. That's what I said here, basically, okay. That's exactly what I said here. I put n to 6 and I point z to n, okay, and then I assign to m the value to which z is pointing to, right, the variable to which z is pointing to, and then I change that variable, that is star z, I change to 9. Then m doesn't change, but n will change, okay. That's what we see here, okay, because z is basically just pointing to this address. So whatever you do to the z, it will change that, right, okay. But it will not change this value, because here we are just given m a content, okay, not just an address, right. So that's exactly what we see here now, we saw here, okay. We just gave the z to point to y, okay, and I took the value of y and gave it to x, okay, and then I changed the z, okay, but z is actually is a pointer, remember. So I changed the value of z, it means it will change the value, the variable to which it was pointing to, that is, it will change y, okay. So y will change, x will remain the same, and that's what we saw here, okay. When I printed it twice, first time both were 10, and then the y changed, the x remained the same. Okay, so that's the summary. Okay, the changing asterisk set changes n but not m. Yep. Okay, so now we look at the next one, that's the arrays. Okay, so we discussed pointers. Okay, now we look at arrays. Yeah. Okay, so arrays, here is a example of that. I am declaring an array x integer type. Again, arrays also have to have the data type, just like pointers and other variables. Arrays also should have the data type. Okay. So here it is an integer data type. Array x is an integer data type. So its 4 is the dimension of the array. Okay, that means we can put 4 different values into this array. Okay, we will see that. So the elements, there are 4 different elements in this array. So the elements of this array are x0, x1, x2 and x3. Yeah. Remember, it starts from 0. Okay. So that's special. Remember this always. When you dimension array as 4, it basically ends at 3 because it starts from 0. The counting starts from 0. Right. Okay. So now we use a square bracket instead of a bracket like this. So just to distinguish it between a function and an array, right? Instead of a simple bracket, we use a square bracket. Okay, so now we'll see some uses of it, and then we would have more clear idea of what it is. Okay, so here is a small program which declares an array and a pointer, okay? And then I am saying that num equal to x. Okay, so now this is interesting point here. So it says that num equal to x if I say, okay, actually num points to the first element of the array. Okay, we could also say num equal to x of 0, it's the same. Okay. But if you want the pointer num, okay, to any other value, okay, then you have to say x of 1, x of 2, etc. Okay, so that's what we would see. For example, num equal to x of 3, I have to say. Okay, will point to x of 3. Yeah. Okay, so now we will see some example of this. Okay, before we go into this thing, we'll just see some examples of this. So NUM plus plus. Okay, we can also do some arithmetic with it. That is, we could say NUM plus plus. Okay, that will increase the pointer by 1. Okay, so we would see the examples of all this. Okay, we'll see. So when we say plus plus, we would actually set the pointer to the next element of the array. Okay, so that's what we are going to see here in an example. Okay, so here is an example, okay, which uses both an integer array, okay, and a character array. Okay. So character strings are actually arrays. Okay. So if I say here, for example, I have declared course as an array, okay, so it's a string, numerical methods. So if I say course 0, it will pick up n. Okay, course 1, it should pick up u. Okay, so that's what we are trying to show here. Okay, so let's just execute this program, and then let's go through this first, and then see what it should do. Okay. So when you want to print a character, you use %c, okay, and you want to print a string, you say %s. Okay, so here we are going to, when you say %s course, okay, now I said course is a string. Okay, so if I say course, it will print the whole numerical method. Okay, so it's, while course 6 is an element of that array, so it's one character. Okay, so it will print out the 6th character on this, that is 0, this is 1, 2, 3, 4, 5, 6, right? So it will print out the 6th one. Well, that's what you have to see. And then similarly, I have trying to show you that if I say %course 0, okay, it will also, sorry, ampersand course 0, it will print exactly the same thing. Okay, so these two mean the same thing. Okay, because the course is also a pointer, the ampersand, the code, okay, the S, an array name is also a pointer to it. Okay, that's what we are trying to see here. Okay, so we will see this and that here. Okay, and then there is the use of an array, an integer array, where I am putting the initializing the integer array using an assignment statement here. Okay, so I run the I loop, this loop from 0 to 5, and I am putting in that into this array. Okay, and then I can actually pull out the values from that array using this sign, because k, which is the name of that array, is also a pointer to that array. Okay, there are two things which we want to see here in this program. Okay, so we will see that in a minute. Okay, so as I said here, there's some pointer arithmetic, that NUM plus plus and NUM plus 2. Okay, so NUM plus plus sets it to the next element. If you want to go 2 elements ahead, you can say NUM plus 2. So it sets the pointer to the 2 elements ahead. Okay, that's the integer array which we used here. So I have an example of that here again. Okay, so I put in this value. Okay, and the array name is also a pointer to the start of the array. So what I wanted to say in these two slides was, one is that I can define an array using a statement like this. So this will have array elements starting from 0 to 9. Okay, and then I can assign this is not a complete statement, this is not a full program statement. Okay, it is just an indication that I am going from starting from I equal to 0, and I am going in steps of 1. Okay, I plus plus. I should actually put in a so that's what I wanted to say. I want to run this loop, okay, and I want to put up to 9. I can go up to 9 inside this. Okay, and this, if I say now n, okay, n is actually a pointer. Okay, just say n, then n is a pointer to that array. That's what I'm doing here. I'm saying that k is now a pointer to the array which is 5 elements here, 0 to 4. Okay. So I can say star of k plus 2. Okay. So I would remember note this bracket here, this is required. So star of k plus 2. Okay. So it will take the second element of this array and return its value and gives it to j. Okay. So that's what we will see. Okay. So we will just print out this. I will just run this program and see what we get. Okay, so that's what it's printing. So let's look at that. What we wanted to print. We want to print it using two different ways. I said cores of 6. A core is 6. That's the sixth element of the array. So that turned out to be C, right? And so that is 1, 2, 3, 4, 5. Okay, that's starting from 0. 0, 1, 2, 3, 4, 5, 6. That's the sixth element of the array. Actually, seventh element of the array. This cores of 6. That's seventh element, starting from 0. And then I am printing out the cores, which is a string. So I get here the element is 6, but the string is numerical methods. And I am printing the same thing in a slightly different way. Again, I am printing the sixth element here, as the seventh element, 6. And I am using ampersand cores 0. So it's actually pointing to cores. Okay, because cores is a pointer, okay, to the array. Okay, so I can get the same thing by doing that. So all array names are pointers to the array, okay, to the first element of the array. But it's a constant pointer. You can't change it. Okay. So that is, it's a constant pointer. Okay, there is a difference between this and the other pointers. These are constant pointers. You can't change that value. Okay, it always points to the first element of the array. Okay, so that's the difference. Okay, so here again I had this, so similar to what I have shown here. I had this k of I equal to 3 star I. Okay, now I want to pick up different elements of this array. I can use k as a pointer for that. Okay, but k always points to the first element. So I had to use, if I want to point to other elements, for example the third element, I have to say k plus 2. Okay, so then that points to the third element, that is k of 2. Okay, that's what we printed out here. Okay, and we got it as the same 6. Right, but remember we would say if it's a normal pointer, if k, we could say asterisk k, right, the star k would return the value to which k is pointing to, right. But since you want to point to a different element of the array, right, okay, you have to increment that pointer. But when you do that, okay, that increment, okay, since k is a constant pointer, okay, you have to use this bracket. Okay, that's the important difference between a pointer declaration and an array pointer. Okay, so now we will see that, summarize that again. So m equal to n of 0 and m equal to star n, okay, are the same thing. Okay, there's the same effect. Okay, so that's what we just saw here. K of 2 and k plus 2 give the same value. Okay, so that's exactly what I demonstrated here to you, that if I say k plus 2 and I take the star of that, okay, or I say k of 2, I get the same values in the thing. Okay, that's what we just demonstrated. Okay, so here is a summary of the character strings which I showed. Okay, so the course is again a pointer to that character array. Course 0 is now will be initialized to n, and course 1 to u, etc., right? Okay, then course 16 to initialize to s. Okay, so that's what it is. That's what we just saw again in this program. Right? We did exactly the same thing here. So it's just a summary of what we just saw in the program. Okay, so now let me, before we go into the next thing, okay, let me just give you a fact list on pointers and arrays. Okay, so all pointers are addresses and must be initialized before we use it. Okay, so the result of operations that modify pointers depend on the type of variable to which it points to. Okay, by which I mean that how many, when you change the address, right? When you say that a is a pointer and I say a plus plus, what does it mean? Okay, so how many, what is the change of the address? What to where it is pointing to will change depending upon whether a is an integer or a is a 32-bit floating point or a 64-bit floating point, etc. Correct? Okay, that's what the meaning of this statement is, that the result of operations that modify pointers depend on the type of variable it's pointing to. Okay, so the name of an array is a pointer constant to the first element of that array. Right? Okay, we saw that just now. Okay, and when you create an array and when you use it, okay, care should be taken not to exceed the bounds of an array. Okay, now this is a warning for all C program users that C compilers do not check the bounds of an array. Okay, so as I said here, that when I say K5, okay, it can only store 5 elements starting from 0 to 4. Now, if you try to put a fifth element, a sixth element to it, okay, the compiler does not check it. Okay, right. So you should take that care. So this is the price you pay for some flexibility. So this can have disastrous consequences if you exceed the bounds of an array, okay, because it can write to some other memory location and it can be disastrous. Okay, so now before we go into, we have the concept of pointers to pointers, we look at some more examples of pointer arithmetic, okay, and we'll get more familiar with pointers. So here is another program which would demonstrate the use of pointers. Okay, now this is a little longer one. Okay, so now I have used here two different character pointers. Okay, that is a star letter. Okay, and a pointer array. Okay, so now this has 4 elements in that array. Okay, and I have used another character array. Okay, so there is a pointer array here. Okay, or a list of pointers, okay, and here is a single pointer, and then I have a character string. You know, 3 different quantities here. And similarly, I have an integer array and a pointer, okay, a set of pointers here, right? And I just want to show in this program how do we use this. Okay, so I can say, for example, now course 0, course 1, course 2, etc. are pointers, right? So I'm using course 0 here to point to numerical methods. Okay, and I'm using course 1 to point to programming and programming. Okay, there are 2 strings which I'm pointing to. Okay, so now if I print that using this statement, that is, both are strings, right? So I will get numerical methods and programming. Correct? Okay. So similarly, I have this array here, an array M. So I just run it up to fill it up with this assignment statement. M of I equal to 3I. So M of 0 is 0, M of 1 is 3, M of 2 is 6, etc. And then now I am pointing K of 0. So now I have a string of pointers here, okay, integer pointers, okay, and I am pointing that to M of 1, and I am pointing K of 3 to M of 4. Okay. Now I can do some, so now these are pointers, okay, and I can subtract 2 pointers. Okay. I can do a little bit of pointer arithmetic, so that is what this is, just to demonstrate that. Okay. So I can do K of 3 minus K of 0. I can, and then I can get an integer there. Both should be careful when you use this kind of pointer arithmetic that both pointers should be of the same type. You can't subtract an integer pointer from a character pointer. Both has to be the same. If you have similar type of pointers, and then we can use that, and we can subtract like this, and we will run that. Okay, and then let's run it up to that. Okay, and I have commented the program beyond this. Okay, so that this is a common statement which you might know, which is basically an instruction to the compiler that you ignore everything starting from this to this. Okay, so the program ends here. So the program basically stops by printing out the value j, which is the difference between these two pointers. Okay, and it would print star k of 0 plus 1. Okay, so I said k is also a pointer to the array, to the first element of the array. Okay, so it will print that. Okay, and then it will also print star k of 3. K of 3 is pointing to the fourth element of the array. M of 4, the fifth element of the array. So let's compile this and then print it, and then see. Okay, so we have the numerical methods and programming printed, and we have 3, 6, and 12 printed. Okay, let's go back and see what is this. Okay, so first, that when I subtract, okay, k of 3, okay, from k of 0, okay, I get the difference between these two pointers. Okay, one is pointing to the 0th element, other pointing to the third element, so you get 3. Okay, you can do that only if, so basically you can get this. Use this to check the length of a string. Okay, that will be the use of this. Okay, so if you want to know what the length of the string is, you could actually take the pointer which is pointing to the first and the last element and take the difference. Okay, we will see the use of that later. Okay, and then this k of 0 plus 1 is pointing to the second element. Okay, and the k of 3 is pointing to the third element. That's what we just saw. K of 3 is the fourth element. Okay, that is 0, 1, 2, 3. Oh, sorry. K of 3 is pointing to the fifth element. Okay, m of 4. Okay, that's what we have printed out here. Okay, so I assigned k of 3 to the fifth element. That is, first element is 0, second one is 3. And the third one is that is m of 2 is 6, right? And m of 3 should be 9, and m of 4 should be 12. Okay, that's what we printed out. Okay, and so that's what it's pointing to. While k of 0 is 0, and k of 0 plus 1. Okay, that's what we printed here as 6. Okay, sorry. So this is the same as, I'll just show you, this is the same as using this, and this would give, so I could use m, which is a pointer, which is the array name, as a pointer, and use that. Okay, or I could use k, which is a pointer itself. Okay, so I could use, I've assigned k of 0 or k of 3, I could use both of them here. I could use k of 3 also, which is another pointer. Okay, okay, so it print out 0. Okay, so it is, so I could use here a pointer, or I could use the array name. Okay, one of them. Okay, in this thing, and so this program basically demonstrates that you can subtract same type of pointers. Okay, different element that will give you the array element, and that you can use either pointer itself here, or you could use the array name. Okay, both are possible. Okay, so now the second part of the thing is that I'm pointing this pointer letter to course 0. So I'm pointing it to, remember, course 0 is numerical methods, and I'm going to point letter into the course 0. Okay, and then I'm going to now subtract, I'm going to run through a loop. Okay, and I'm going to increment every time the letter pointer by one step. So it will point to the next element, etc. Okay, right. So remember, the first time when I said letter and set it to course 0, course 0 is my string numerical methods. So it will be basically pointing to n. right, that is the first element, right, and then I would say letter plus plus, so that means it will point to u, right, and I am going to subtract that pointer, okay, this pointer code 0 from this pointer, okay, and we'll print out what the value we get. So we get an integer there again, okay, and the value of that pointer, or the value to which it is pointing to, okay. So that's what we are going to run now, okay. So I uncommented that, and I'm going to run this. Okay, so that's what I'm going to run. We're getting. Okay, so first its value is 0 and it is pointing to n. Okay, and then I'm incrementing the pointer. Remember, I'm incrementing the pointer every time, so it keeps pointing to the different letters of that string, right? Okay, and I get when I subtract from that, I get the difference between the string and the initial point, right? Okay, so remember, this is pointing to the first element of that array. It's a pointer to the first element of that string, right? Okay, course 0 is a pointer to the first element of that string. Okay, so and when this was pointing to the same string, you got 0, and then as you increment this, you keep getting the which element of that string you are pointing to. Okay, so that's one of the examples of pointer arithmetic. We will now look at pointer to pointers. In the previous section we saw pointers, okay, which was pointing to variable memory, and now we are looking at pointer to pointers. Okay. So that is defined as this one, that is character double asterisk marker. So the marker is now a pointer to a pointer. That means that if I define a pointer like this, for example, there is an array character string here called course 0 and course 1, and course 0 is numerical and course 1 is called the string methods. Okay, so now I can use this. So we know that this course 0 is now will point to the is a pointer also, right? Since it's an array, a string, character string, it's also a pointer. So I can use this marker, this pointer, to point to this pointer to read out each of these characters in this string. Okay. So that's what we were going to show here. Okay, so now for example, I make this assignment here that marker is equal to ampersand course 0. Okay, so now marker is pointing to the base address of course 0. Okay, that means it will be pointing to n in course 0, and then if you say so that is to the numerical, that is it will be pointing to the base address n, and then we say marker plus plus. Okay, so now you remember marker is now a pointer to this pointer. Okay, so it's pointing to this particular pointer which is course 0. Okay, and now when you say marker plus plus, okay, then it will point to the next element of that character array. Okay, so it's a character array here, that is course 0 and then course 1. So if I say marker plus plus, it will then point to the next element of that character array. Okay, that will be to methods. Okay, so then you can also, so now that's going from one string to another string. Okay, but we can also use the same to point to the different elements, and for that we would use this way. So now marker plus plus, remember marker plus plus has taken this pointer to the next element which is course 1. Okay, and then now you say so this asterisk in a bracket, asterisk marker plus plus. Okay, and then it will start moving along this along the string. So when it say marker plus plus here, it was pointing to the base address of this, that is pointing to m, and when you say asterisk marker plus plus, it will point to the next element. Okay, and the next element, etc. Okay, so it will point to it will now point to e, and then if you say marker plus plus again, it will point to t, etc. Okay, so we'll see that in a program. Okay, so here is a program which shows that. Okay, so we have the standard assignment statements. Sorry, the compiler preprocessor commands. Okay, and then here I have declared a character, a pointer called letter. So this pointer is of the type character, and then you can see that I have one asterisk sign here, so it's a pointer. Okay, and then I have a string here. Okay, and the string has a character string here. The character string has 3 elements in it. So, course 0, course 1 and course 2 I can put in. Okay. So, there are 3 elements possible, course 0, course 1 and course 2. So, that is another pointer string. And then I have a pointer to a pointer, that is double asterisk marker. So, then I put in this here course 0 as this whole string called numerical methods, and course 1 I said and programming. Okay, so, this is 2 strings, okay, course 0 and course 1. Okay. And then I would say that marker is to this marker, that is this pointer to the pointer, okay, to point to course 1. Okay, that means it will point to and programming, right. And then if you say that, now that's, remember this one is the way to print out the character strings. Okay, so now you say %s, and then I am printing out course 0 and now star marker. Okay, so let's see what this prints out. Okay, so now it prints out here. So I'll show you what it prints out. So if I run this program, okay, so it prints out numerical methods and programming. So the first printout here it is course 0. So the course 0 is numerical methods, right. And now then you have the star marker. So the marker is pointing to course 1. So that is to and programming. So I can print the string out by just writing here course 0 and then saying course 1, or I could use as course 0 and say this star marker. Okay, so marker is, remember, simply marker will not give you that value. So it's a star marker that is actually pointing to course 1. So, okay, so you will get in that print statement, you will get this entire statement here saying numerical methods and programming. That's one way of printing that out. Okay. Now if I say marker minus minus, that means you go back. Okay, now it will point to course 0, right. So it was pointing to course 1 here. Okay, then it points to course 0, that is the numerical methods. Okay, and then if I say course 0 here, and then I say star marker, okay, and that is what this part is. So that will print out numerical methods and numerical methods twice. Okay, because now the star marker is pointing to numerical methods because we set marker minus minus. Okay, so that's a way to go forward and backward on the using a pointer. Okay, so here again, now if I say marker plus plus, then it will again take it back to course 1, and that is to point to programming. So that's the thing. And now once we have the mark, now this one, now as I said, now this is taken to marker plus plus, that is means it's pointing to now and programming, right. And then now to print out, now we try to print out each of this characters inside this string, right. So that string has course 1 as and programming, right. So that's what we have, string, and then the gap there, okay, blank. Okay, so now we try to print out all of that. So that's the way to print out that. Okay, so as we said earlier, that we say star marker plus plus will take us one step forward. Okay, and then you say star of the star marker plus plus will print out that variable. Okay, and now if you want to print one character, you use this %c. Okay, and if you want to print out a string, then you use %s. You remember that. Okay, and now I am going through this in a loop, okay, for starting from I equal to 0 to I equal to 13 in steps of 1, that is this for loop is doing starting from I equal to 0 and it goes to I less than or equal less than 13, that means I equal to 12 in steps of 1, okay, and each time it will print the I value, okay, and the value which is inside the string, and that's what you would see here. Okay, and that's what this printing. Okay, so I value and the string. Okay, so the third element, the fourth element actually is a blank. Okay, and then it's printing out each of these elements here. Okay, so that is up to 12 we have printed. Okay, that will give you all the way up to mi. Okay, so before we stop, just to reiterate this once again, that we were looking at here pointer to pointers. Okay, so that is we can also use this to read out array elements. Okay, we will see that when we read actually when we look at arrays, we will use this thing again. Okay, so but here we are using now a character string, okay, which is similar to arrays. Okay, and I am trying to read out each of the elements of that string by using this using a pointer, okay, which points to that pointer. Okay, and then I increment the pointer by marker by using this plus plus. Okay, that takes it from one array element to another array element. While I want to go through the array, okay, I will use that using star marker plus plus, and now if I put another star on that, okay, I can print out the value which it is pointing to, and that is what we see in this thing here. Okay. So, we will stop today's lecture at this point.